Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Alicia Juarrero. She's a president and founder of VectorAnalytica, and today we're talking about her latest book, Context Changes Everything, How Constraints Create Coherence. So, Alicia, welcome to the show. It's a big pleasure to have you on.
Thank you. It's an honor. Thanks for inviting me.
Okay, so starting at the beginning, you start the book by talking about issues with identity. So, and you address questions like, for example, how is change compatible with remaining the same? So, could you start by telling us what is identity and perhaps explaining why this question is so important in the context of your book?
I think what I tried to do was to use the idea of identity as an example that illustrates very basic philosophical questions like cause and interdependence and that sort of thing. And we historically in science as well as in philosophy, people have identified identity with what Aristotle used to call primary qualities, namely internal properties. In the case of matter, it would be atomic weight, that sort of thing. But then Plato said, well, it is the essence of the individual thing that confers upon it its identity. And so it was always viewed as an internal standalone characteristic. And I think that has led to a lot of, who am I? And the idea being that I am born with some kind of identity and therefore I either have to express it or I have to figure out what that is. But I think what complexity theory gives us is a whole different notion of identity in the sense of interdependence. And so I start, I think, a little bit as a teaser, using the example of identity to draw people in because it's, I think, a subject matter that is very much in the public discourse. But I wanted to use it to show that maybe it's thinking of it that way that has led us into a lot of paradoxes and problems. And whereas, what if we started thinking of it in a relational way rather than in an essential property way?
And so in the book, one of the things you do is that you try to tackle what you call three erroneous ideas about three central issues. One of them is the problem of types or kinds and essences. Another one is the problem of interactions and relations. And the third one is the problem of causation. And before we go through all of those problems, let me just ask you this, because at a certain point in the book, you allude to the fact that maybe Western science and philosophy are not well equipped to deal with the relations between parts and wholes. So where does this way of thinking come from that perhaps pose an obstacle for us to be able to better think when it comes to those relations?
I can start by saying it doesn't come from Aristotle and the Greeks, for example, because Aristotle did believe that an organism was a substance, and that is a whole, W-H-O-L-E, that hangs together as a coherent unit, as opposed to a clump, a pile of debris in your backyard and construction debris. That is not a coherent whole. That is a pile of stuff with no rhyme or reason, with no logic. But Aristotle was able to account for that because of his notions of formal cause, and we can go through that later. But once in the 17th century, in the scientific revolution, atomism became more prominent. The idea, again, that the essence of something was in its fundamental, unchanging property.
Okay.
And so if that's the case, what philosophy found itself inevitably concluding was that wholes, again, WOLES, are epiphenomenal. They have no integrity of their own. They are simply the sum of their component parts. They are simply aggregates. Once that happens, then you have no way of showing how, for example, homeostasis works, or things that are holistic systemic properties, how they can influence top-down their components, or indeed how the components created those organic coherent wholes. And so the answer was always Deus ex machina, or it's some élan vital that comes out from elsewhere that impinges on that atom or whatever and gives it life. And of course, that's Frankenstein, right? But it's inevitable. That's the inevitable conclusion of the premises that the essence has to be an internal, usually at the minuscule level, at the lowest level, component.
Mm-hmm. And I guess that this would get us into discussion surrounding reductionism and emergentism. And when it comes to reductionism in Western science and philosophy, to a certain extent, we are also trying to reduce things as much as possible. Ideally, we should be able to reduce it to atoms or some sort of particle like that.
Yes, exactly. You know, and then it's always look down, 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 see what we can find, the basic fundamental building blocks. And what that implies is that therefore all causality works bottom up. All causality works from the properties of the quarks, or whatever happens to be the lowest level that we figure out is the case, upwards into what we see as, you know, a television monitor, an organism, an ecosystem, and so on. So influence always goes bottom up. And so the idea of reductionism is to try to see if we can go all the way down. And in physics, of course, that's the promise of a theory of everything, right? Once we understand that fundamental level of reality and how they connect, then that should be able to explain everything, including our psyche, our mind, social organization. Everything goes up. And I think that, again, if we think of relations as important as fundamental component stuff, then that changes everything. That's why I named it, the book that.
Mm-hmm. And by the way, just before we go back to the problem of causation, you say that the central subject matter of your book is the generation and preservation of coherence and its emergent properties. So what is coherence exactly?
Well, I use the word coherence and wholes almost simultaneously, in contrast to aggregates or clumps. Mm-hmm. or masses. Because what I want to emphasize is that an organism, for example, but it's not just reified stuff, but dynamical relationships hold together as a whole. And I want to call that the emergent property of causes. And so I think that complex dynamical systems theory gives me a way of explaining how that emergent whole occurs without having to resort to spooky élan vitals coming in from the outside. It gives me a scientific, respectable way of explaining how emergence occurs. And what I mean by emergence is the novel properties of coherent structures. And I mean coherent structures dynamically as well as materially, that new novel properties that do not exist at the level of the component parts, even though the wholes are, reductionists would love to say, nothing but the sum of their parts, but they are nothing, I want to say they are nothing other than the sum of their parts, but they are more than because they have properties that the component parts don't have. Example, a laser. A laser can cauterize wounds that each component photon stream cannot. It's the interrelation that makes, that is the source of the emergent properties. That's what I want to say. And you have the same thing in soldiers marching across a bridge are told to break ranks because they might collapse the bridge, or fans at a stadium stomping in unison, in synchronization, which is the interdependence among each individual stomp. One person stomping on the stadium will not collapse the stadium, but when it happens in synchrony, you have properties that are not the case in the component parts.
And so you mentioned dynamic systems theory there. We'll come back to that in a second, but just going back to causation for a bit, because I want the audience to really understand what we're talking about here when we talk about causation. And for example, in the book, you talk about Aristotle's four causes: material cause, final cause, formal cause, and efficient cause, and how Western science, and again, we've already mentioned this a little bit earlier, tries to reduce everything to efficient causes. So could you explain what each of those causes...
Oh, each of them? Sure, absolutely. And I think Aristotle got it from the potter's wheel. You know, the new technology at the time, the potter's wheel. We think of the computer today and we think of things in terms of, I'm sure he got it from the potter's wheel. Anyway, so you have a lump of unshaped amorphous clay. That is the material cause. And you decide you're going to make a picture, all right? And the concept of a picture is the formal cause of how that clay is going to be shaped. And formal cause and final cause are intertwined very strongly in Aristotle, and that is the formal cause incorporates the final cause. The purpose, the end point of a picture is to pour liquids. And so you want to make sure that you have a little funnel at the end of the picture, otherwise the water, it won't be a well-designed picture, and so on. And then efficient cause is the potter's hands imparting energy into the process to bring about that final result. So Aristotle was able to account for wholes that way, not only in inanimate objects like a picture, but also in living things. For Aristotle, formal and final cause were built in. So for Aristotle, every living thing has a built-in telos, a built-in end point, which is its formal cause. And the easiest way to understand that is an acorn has, in a sense, a built-in telos to become an oak tree, and that incorporates the characteristic, typical, type-based shape of an oak tree. And the purpose, of course, was to be part of God's whole, so on. So, which the Church very easily incorporated in. That's why Maimonides and Averroes and Thomas Aquinas were all Aristotelian. It fit in very nicely. But with the scientific revolution, formal and final cause get kicked out, saying, oh, this is part of medieval theology. That has nothing to do with science, Bacon's empiricism, and so on. And material cause, well, we'll figure that out with observation. So really all that's left to figure out is efficient cause. And that's why it seems to me that even to this day, science and philosophy of science consider the word cause to be appropriately and correctly used only when it refers to efficient cause. And since I was interested in looking at other forms of influence, then I said, I knew I couldn't fight the battle of fighting and trying to change people's usage of the word cause. That was a losing battle. So my question was, what am I going to do? I've got to find another word, and constraint ended up being that, and we'll talk about that later. But those are the four causes, and the reason is that today, if somebody were to ask, what is the cause of Y, you'd find X, and the cause is always some force that imparts energy to an effect, period. That's it. That's the only appropriate, correct use of the term cause. And that raises all sorts of problems as, well, how does my intention to do something fit into that model?
Right. And so, I mean, in the framework you're using in this book, you take into account all four different kinds of causes that Aristotle identified, or
Well, I
not?
don't want to go back to that terminology, formal
Okay.
cause and final cause either. I think that the concept of constraint, which has been used in mechanical engineering and in a lot of scientific disciplines, can help me do what Aristotelian formal cause without looking for trouble and having people say, oh, she knows she's going back to Aristotle, that we can ignore that. No, there's a lot of, because biologists understood, but biology, and of course, more recently, ecology, I think was a discipline that never accepted that idea that it's all efficient causality. They understood the importance of these relationships. But the problem was we did not have a model, we did not have a vocabulary, we did not have a way of understanding how to frame this kind of thinking.
Mm-hmm. Okay, so just before we get into constraints themselves, dynamical systems theory. So could you explain what that is exactly about and how do you use it in your approach here?
Let me explain. I've been thinking about, let me go back. I've been thinking about these issues since I was doing my PhD dissertation. Because it was on ethics, how do you explain behavior? And we tend to explain behavior. The first sentence of my first book was, what is the difference between a wink and a blink? And the difference is, well, a wink is caused, that's the way we explain it, an intention, whereas a blink is caused by, I threw some sand in your face and you blinked, all right? Mm-hmm. Okay, so then the next question is, how does an intention cause, right? And of course, even back then, it was very obvious. It's not one neuron pushing another neuron, pushing another neuron, pushing the muscle and the arm. No, that's not going to work. So then the question is what? And I was fortunate enough to really have a lot of friends who were in operations research and systems analysis and network theory way back when. And as I would hear these engineers talking, I think to myself, you know what? This has to be a network phenomenon. This has to be some kind of a network theory. But back then, the only thing you had was system science like Ludwig von Bertalanffy, and there wasn't that much back then in the concept of how a systemic property can influence the components and how it even became a systemic whole rather than a clump. And so as I moved to Washington, D.C., and the National Institute of Health is very generous, and you can go in and sit and listen to lectures. I don't understand any of this, but people like Walter Fontana and people from the newly created Santa Fe Institute would come to speak, and I go, it's not just networks of electrical circuits. It's networks in a lot of different dimensions. And so how can I understand this? And I was lucky enough to, at the time, Ilya Prigogine and Isabel Stengers published the book, or La Nouvelle Alliance, Order Out of Chaos. And I read it coincidentally at the same time that I read Kant's Critique of Practical Reason. And in Kant, his critique of practical reason is an attempt to explain purposiveness, teleology, final cause. But remember that Kant had really bought into Humean notions of causality. So when he looks at a tree in the Critique of Practical Reason, it was the first thing I almost ever published, he says a tree is produced by the leaves, but in turn produces the leaves. It's a circular form, and he says that is unlike any causality unknown to us, because efficient causality is linear. The idea of circular causality, even Aristotle didn't like that. That's a whole different story. So he says it's something unlike anything known to us, right? And so that's why Kant relegates purposiveness to the regulative judgment. All right, end of first act. And then I'm reading Prigogine, and he, of course, gets the Nobel Prize for dissipative structures, for the idea of dissipative structures. What's a dissipative structure? The example is you have a pan of water or any viscous fluid heated uniformly from below, and at the beginning it gets warmed as a conduction. You start a gradient, and the gradient means it's a bit warmer on the bottom than it is on the top of the water, and that continues as you either crank up the heat or it just continues. And then at a threshold of instability, little internal fluctuations of linked molecules begin to appear. The problem is that when the gradient isn't sufficient, the overall context dampens that initial little perturbation, and it continues as a conductive process. But imagine that it gets warm, hotter and hotter and hotter, and at a critical threshold of instability, you get an entire phase transformation where millions and billions of molecules of water in a small pan of water link up to produce what is known as Rayleigh-Benard cells, these hexagonal rolling columns of fluid, boiling in the layman's terminology, but they're very structured. They're very structured, but the exact order in which they roll depends on the initial conditions. It doesn't always happen at the same time. And most importantly, once that phase transformation occurs and an individual molecule of water is caught up in one of these cells, it changes its behavior such that it behaves as if it knew what the others are doing, such that the overall convection, these are called convection cells, make the individual molecule of water behave only in a way that maintains and preserves that convection cell which it formed, but now in which it is now constrained top down. And I went, that's Kant's causality that is unknown to us. Look, it's science. He got the Nobel Prize. I won't get into trouble if I use that as my model. It's not Bergson's Elan Vital. It's not Descartes' dualism in order to explain how this works. It is a way to explain through non-open systems, far from equilibrium, thermodynamics, which is not your grandmother's thermodynamics from classical thermodynamics that just degrade towards stasis and equilibrium. This increases order, increases complexity in a circular fashion that is self-organized. they are open systems. Yes, there is energy. I don't want to deny efficient causes. But what I want to say is there is a whole different dynamic going on simultaneously. And it is, and therefore, the characteristic dynamic of a Bernard cell, whether it's water, whether it's, I don't know, other viscous fluid, coffee, whatever it is typical. And so, well, could you think of formal cause as the essential characteristic of these dynamical wholes? But they're each individually different. They're each, because they will have characteristics. The size of the convection cell will depend on the height of the pan of the, so the initial, and notice, if you've got a pan of water, the height of the sides of the pan don't transmit any energy into the convection cell. Those are not, their influence on the characteristics of each cell are not efficient causal kind of influences. So I thought, well, what are they? And then I started looking, and sure enough, every time scientists start talking about things like initial conditions or so on, they start using the word constraint. I thought, so Kant's kind of causality unknown to us are these kinds of influences and another word scientists use is factors. Well, yeah, tell me, how does a factor cause? But they don't want to use the word cause because cause equals efficient cause. So therefore, I thought, you know what? I'm going to start using the word constraint to explain how these phenomena, like how a sufficiently steep gradient will precipitate, it can always collapse and disintegrate, but if it can precipitate a phase change to a higher form of organization, and that gives me a way to, well, maybe the mind is one of these forms of high-level organization because it would be a network property the same way the molecules of water that are rolling are networks of molecules of H2O.
So you've already mentioned what constraints mean, but there are different types of constraints, right? And you go through at least some of them in the book. So tell us perhaps first about spatial and temporal constraints.
May I back up and speak first of
sure.
enabling and restrictive constraint? The problem with using the word constraint, of course, is that that word has a particular connotation in general as well, and that is of limiting alternatives.
Right.
But biologists and Prigozhin, he was the good Prigozhin back then, the bad Prigozhin. Now, he would use the terms enabling constraints because the initial conditions, the gradients, and so on, all are enabling conditions. Enabling of what? Enabling of the generation of a form of coherent dynamic, the circle, the organism, and so on. And so even though, yes, each individual molecule's space of behavior space is narrowed, as I explained, once it's entrained and caught up into one of these convection cells, overall, there are degrees of freedom open to the cell as a whole. In other words, the cell in my liver or in my stomach is constrained to behave as a liver cell or as a stomach cell, as a gastrointestinal cell. But overall, the whole, the organism that they generate has many more degrees of freedom than it would have if they were only individual isolated cells that were not enabled to generate a larger whole. So I think you start out by thinking of enabling constraints and constricting. But I didn't explain myself very clearly in that once the organism coalesces as an organism, then what I would like to say is it exerts top-down limiting constraints on the behavior of each individual component and levels of components, and that is what we call homeostasis or allostasis, which is adapting to changes. It's not a force from outside. It's not a force from, there's no one neuron that is the homunculus of old. Again, that's why we used to think of homunculi, because that was the only way we could understand the notion of cause. There has to be another agent that is directing everything. But what's interesting to me is that this probably applies in social systems as well. We used to think of organizations as being always directed top-down by one ruler, by one CEO that has authoritarian power. But we now understand that very large systems have to be controlled top-down by distributed dynamics, because there's no way you can anticipate all the changes in the system. I'm getting too far ahead of myself. But that's of course what I'm interested in the end. That's what makes it interesting, that there are analogous properties almost at every stage of dynamical systems. It spans physical, chemical, biological, psychological, each of which has different emergent properties, but there is an analogous dynamic of enabling constraints, generating a more complex whole, which in turn has emergent properties that are different from those of their components, and that keep that whole at that level from dissipating into nothingness. It keeps it integral. I like the word integrity because, again, that spans physics, chemistry, and human beings. But in physics and chemistry, its integrity means, the thing didn't fall apart. When I heated it, it held. It held. What holds? And I think what holds is a constraint regime. It's a system of interlocking constraints that hold the thing together.
Yeah, so there's that expression that people tend to commonly use, at least in certain contexts, where they say that the whole is more than the sum of its parts, but in this case, perhaps the better way to put it would be something like the whole is different than the sum of its parts.
It's different, and the only sense in which one would say more is that it has differently more properties. Mm-hmm. Because even the slime mold, which is the darling, this bacterium, the slime mold of complexity theorists, it can move when it's coalesced as an organism, that each individual spore or whatever it's called of the slime mold can't on its own. So it's not only different, it can do more. It opens up dimensions of freedom or degrees of freedom that the components didn't have. But it's, I think what I'd like to say, it's certainly not other than the components, which is what our way of understanding traditional classical ontology was. The cause must be other than the effect. And this is not other than the effect, it's that circular causality that Kant said we have nothing that we can explain it as, and I think now we do. That's the whole reason why I'm attracted to complex dynamical systems theory.
Mm-hmm. So in the book, there are two types of constraints you talk about. One of them is context-independent constraints, and the other is context-dependent constraints. But what does independence mean in this particular case?
I'm always in trouble with this because I started in the first book calling it context-free. And I got a lot of feedback saying nothing is context-free. You shouldn't call it context-free. You should call it context-independent. Well, so I started calling, I borrowed from a book from, oh my goodness, it's an old book, 1960, I can't remember, 60 something, from Lila Gatlin. I think it's a Columbia University Press, I can't remember. And it's called Information in the Living System. And she talks about two forms of redundancy, constraints. And she says, context independent, she called it context free constraints, are those that take a system away from equiprobability. Okay, so what does equiprobability here mean? It takes it away from randomness, right? So if I think of an example of randomness, I think of white noise, correct? There is nothing that is more, or no movement that is more or less probable than another, correct?
Right.
So once you have a gradient, you have a situation where you're not at equiprobability. It is not random. There is a direction of movement that is a bit inhomogeneous, unrandom. Or, of course, this works really nicely with Einstein's notion of space-time, because if his idea is that interactions among mass creates a dip, in space-time, that is an establishment of a context-independent constraint. It has taken conditions away from equiprobability. Polarity, I think, is another example of a context-independent constraint. Electromagnetic polarity, you have a positive charge, you have a negative charge, and so if you're here and you're negatively charged, you're going to move towards a positive. The possibility space is no longer like white noise. There are inhomogeneities in possibility space. And I think that is the first requirement for complexification. So you have density gradients, you have pressure gradients, you have temperature gradients. All of these works in early cosmology, right? In the creation of galaxies, in the creation of stars, in the creation of black holes. Now, of course, the question is, well, but if there is space-time gravitation, why didn't everything either collapse into the black hole, get sucked into that incoming energy gradient of mass, or conversely, why didn't everything just dissipate into empty space because of there were no constraints? So the answer is context-independent constraints alone cannot complexify. They are prerequisites for complexification. You need some kind of inhomogeneity. In the Bernard cell, it was the gradient of temperature that we saw. Okay. So then the question is, all right, so if context-independent constraint alone doesn't work, what next? And then the question is, maybe, and this is pure speculation, maybe in a dense enough condition, maybe in a space-time gravitational well, just by chance, some molecules linked up, but that the linkage was more metastable. So that would increase the likelihood that that would happen again. And that would happen again. And if you think back again on the Bernard cell, that is exactly what's happening in the Bernard cell. As the threshold of heat continues, then these initially random fluctuations begin to link up. And then they become a constraint on whatever is around them. Because since they are more metastable, they will integrate, they will attract and integrate into that dynamic. And so what I call context-dependent constraints are what Lila Gatlin called constraints that take a system away from independence. Again, remember, in white noise, each Brownian motion, each molecule, they are independent of each other. And that is our understanding of classical thermodynamics, that why? Because we think in terms of efficient causes. They bump and jostle each other, but they are Markovian, they forget their past. But what happens in the Bernard cell is then they remember where they were and they continue the trajectory. Now, I'm using very anthropomorphic terms. Remember. Well, okay, so let's use the word path dependent, which is what these dissipative structures all are. Prigogine was fond of using snowflakes as an example. They may start out being hexagonal, very similar, but once they fall to the ground, their shape differs because their very architecture of a snowflake embodies the trajectory through time and space, the pressure, the temperature through which it traversed before it reached the ground. So in a sense, that snowflakes remembers in its very architectural shape. I don't want to use the word shape because shape is physical, dynamic, the conditions under which it traversed, and all living things are dissipative structures in addition to being, in addition to non-physical things like tornadoes. Well, why can't we predict tornadoes and hurricanes? Well, because they are complex dynamical systems, because they're like the Lorenz butterfly, they're like the Mandelbrot set. They all remember the conditions and each run is practically unique. Overall, they share a general pattern, like all convection cells share a general pattern. That's my understanding of type. Therefore, instead of thinking in terms of Platonic transcendental types, then this is today's understanding of types. It's a general dynamical pattern, but each run, each individual instantiation or realization of that type is unique because it's traversing unique initial conditions and unique contextual dynamics. And so I think that works. It just seems to work very nicely at so many scales.
And so also as an example, let's apply here that notion of context dependence or context independence to the particular case of public health, which is also something that you've been doing work on. So when it comes to infectious diseases particularly, how can we, using these notions, get a better understanding of how they spread and why it is so difficult to contain them?
It's not only difficult to contain them, it's difficult to communicate with the public about what's going on. Yeah. Because the public, I think it's part of the Western cognitive framework that we think in terms of this philosophical idea. And diseases like polio, one pathogen, one disease, you're exposed, you get it, end of story. But people were going, yeah, but I've been next to so-and-so and I spent 3 weeks with them and I didn't get it and they got it or they didn't get it and I got it. How does this work? And then people started talking about herd immunity and that really freaked people out. What do you mean herd? There was none of that in polio. Well, no, that's not true. Polio was infectious. But for example, in the case of shingles, I don't know how you say shingles in Spanish, for culebri, I think it is. But anyway, it's a disease it's an infectious pathogen, but you don't get it. It's not transmitted person to person. All right. So when COVID broke out and it got so bad, I mean, it's also true for Zika and dengue and all the mosquito or vector transmitted diseases in general. But what's interesting is that once the threshold of instability there is how many people in a society get it. Once they get it, there's a certain antibody collective, systemic network property, that then it is less likely that the individual will get it, because most people, whether they already got it or because they got vaccinated. Why should I get vaccinated? I don't care. Well, because once enough people have this property, antibodies because of either vaccine or because they actually got the disease, then it stops the spread, because it cannot feed anymore on the pathogen. But that is what, and you mentioned it and I didn't answer it a while ago, mereological relationships. These relationships between parts and wholes and wholes and parts. We don't understand how, I mean, when I say we, here it's the general public, it has a hard time understanding how community collective properties can in fact influence each individual. You know, there's a very interesting study about obesity, about if you live in a society that has a very large percentage of obese people, it is more likely that you will become obese, because it's this part to whole, whole to part dynamic. Because if you see people eating fatty foods and sweets and so on all the time, then you tend to do it as well, because that's part of the context and the culture and the society in which you're working, and that contributes to more. So it's that whole part whole that can't sow in the tree, but it's working out in obesity and therefore diabetes rates and so on. But in the case of infectious diseases that are spread by vectors or by respiratory diseases, it's particularly horrible, because, I mean, we saw the mortality rates with COVID. And so it becomes a question of explaining these very convoluted part, whole part relationships to the public, to have them understand. And I think we did a lousy, terrible job explaining that to the public. And that meant to me that disinformation, misinformation had a wide open field to suggest that vaccines are not any good, that this is all a conspiracy, because we didn't do a good enough role explaining how science works. Well, we don't have all the details of these kinds of diseases because they are path dependent, they are unpredictable, just like the tornado. The pathogen will evolve, will transform, and so we have to be adjusting constantly all along, all the time. And it's very difficult to explain. We can't predict a tornado the way we can with eclipses. And people had hoped that diseases would be like eclipses, that everything would be like eclipses. That was the promise of Newtonian science, right? We'd be able to predict to the 20th decimal point 2,000 years from now when the eclipse is going to happen. We can't do that with tornadoes and hurricanes, but I think we have now become accustomed and used to the idea of these hurricane trajectories. And I think we need to explain infectious diseases that way, that people will understand it's a likelihood of getting it, a probability of getting it, not that it's a one-to-one cause effect the way we used to think of as efficient causes. I'm not sure I answered your question. It's a very difficult thing to explain, but that's why this company that I've been involved in, what we're trying to do is to try to see if we could model and provide monitoring and tracking systems that could provide sufficient information to show people how, for example, a disease spreads in a community and how you can stop it by taking certain precautions. And the reason why context is important is, for example, at the beginning of the 20th century, malaria and yellow fever were rampant even in the United States and the Americas, certainly in Panama. Malaria and yellow fever killed more people in the construction of the Panama Canal than did anything else. But once people understood these are transmitted by mosquitoes, then draining the swamp was able to contain it even in the absence of any vaccine. There were no vaccines back then, but contextual measures were able to contain it in a way. You don't care if there's malaria and yellow fever in the mosquitoes out in the middle where there's no human beings. What you care about is that they're going to infect a human being and that person will get sick and suffer and die. So understanding how that context can be influenced such that it lowers the rate of infection, and people back then didn't believe it either. What does draining the swamp have to do with my getting sick? And I don't remember what was his name. I think his name was Snow, who was the first one to discover that it was in the sewers in London that the transmission occurred. And that was the beginning of epidemiology. But I don't think we've done a very good job explaining to the public how that kind of context in which people are embedded, the hole in which the person is embedded, will affect them as individual members of that community.
But okay, so but before we move on to another topic, let me just ask you this, because of course we've not been doing a good job when it comes to communicating information about infectious diseases to the public. COVID, of course, recently was a very good example of that. I mean, health authorities, governments, political authorities, and even some scientists did not do a good job when it comes to properly conveying information. But since, at least in the West, of course, we live in this cultural context where people are brought up with an understanding of causality, that we've already talked about. I mean, isn't really hard in this particular kind of context, at least for, I mean, even if the information is properly conveyed, for people to have a good understanding of what it really means?
Correct. I absolutely agree. That said, you're absolutely correct. That said, we now have what I think is an enabling constraint that is unbelievable, and we don't quite understand how it works either, and those are memes. Correct? Just as genes transmit the rules of the next generation, memes spread. In fact, you can model the spread of memes with almost the same kind of models that model epidemic spread. And we don't understand how that works, but that means that instead of providing this dry kind of information we used to do through journals and scientific lectures, we have to learn how to communicate with the public using these other kinds of enabling constraints like memes and like social media, because what is social media? It's an incredibly powerful, emergent, dynamical network with emergent properties that we are now learning about to our chagrin, because we don't understand how this happens, because we don't have that, and we need to very quickly ramp up to understand how the internet, the web, have produced context-dependent constraints, enabling constraints that take conditions away from independence. Anything I write on the web makes me links me in a very strong way to somebody 3/4 of the way around the world that I've never seen. That you didn't, and so the transmission is not just my neighbor that he became contagious because I had COVID and they get COVID. Correct? It is, but it's the same kind of phenomenon. It can infect your cognitive framework and really transform it. And we need to understand how to influence that. Now, the problem with constraints is you cannot forcefully change them. That is the efficient cause model. That won't work with constraints. You can tell people don't believe it over and over again, and that won't work. So we have to understand why are some more attractive than others? Why do some spread faster than others? Is it necessarily the individual that is emitting that comment? Or is there something in the way it was said or how it was said? And here's where your point about spatial temporal constraints that I didn't answer and I avoided earlier. Here's I think where it comes in. If we understand spatial constraints poorly, we understand temporal constraints even less. Timing, the timing of when that person said that is as important as what was said. And we don't understand that very well. Why? Because traditional Newtonian science was Markovian. It occurred in a time that was featureless. Space time in Newton was featureless. It was empty. It didn't matter if it happened here or there. It was the same thing. It's only the force that impacts on it that matters. Whereas here, the timing of who says what is like the example I give in the book, because it's an example that I think everybody can understand, is in a playground swing, the child that's learning how to swing on a playground swing learns that the timing when they kick is as important as the energy they impart to the kick. The timing does not impart energy. It is not an efficient cause. It's a constraint. Right. Correct? But it's critical otherwise the swing won't swing. And then the other playground equipment that I like as an example, I wish these were mine. I borrowed it from somebody so long ago I don't even remember. is the playground seesaw. The British call it teeter-totter, seesaw. Mm-hmm. And so those have spatial constraints. Why? Because it depends on the weight of the child, that the child has to sit one here and one here, or both of them here, or one here and one here, in order for the thing to teeter-totter. Because the very heavyweight child sits here, the other one is too lightweight, then this is gonna happen. They're not gonna seesaw. So in order for the thing to work, the spatial constraints are very important. That sounds like a stupid example, but we now understand, for example, that when a sperm fertilizes an egg, and you have the initially fertilized egg, and it starts dividing into 2, dividing into 4, dividing into 8, and I can't remember how many are there, but they're all identical. All the different cells are identical. We call them now pluripotent. But if there's one particular cell that is in one position, we know that that will become the neural crest of the developing embryo. So positioning in the developing embryo, why? It breaks symmetry. It gives me the first context-independent constraint. See? And then from there on in, the context-dependent constraints of the genome, which are instructions. A recipe is a temporal constraint. You don't like the word recipe? You think in terms of food? An algorithm. There's a sequence that it has to be followed, because if the same thing is done out of sequence, it won't work. But the sequence does not impart energy. It's an enabling constraint. And it's true that's why the developmental biologists understood this from way back. They were going, no, this isn't efficient causality. This isn't Tonian. There's a whole part-whole relationship. A cell in a petri dish works completely different than that same cell in the liver. Mm-hmm. Why? Because the context is different, and it will do things differently. Well, what kind of causality is that? That the liver is influencing the component part. It's mereological, but I don't want to say mereological causality because I'm giving up that word. Because people will say, oh no, but it's not causality. It's not. No, correct. Interlevel relationships from parts to wholes and wholes to parts are constraint relationships. Herbert Simon understood that when he gave that lecture way back when in the Sciences of the Artificial, where he talks about watchmakers and how watchmakers create modules. And so he understood that levels of organization, the cell, the tissue, the organ, the organism, the digestive system, each level, the relationship between them are are relationships of constraint, not of causality. And so you have people like Stanley Stolte, people like Howard Patty, people like Herbert Simon. All of these people understood that from way back when. Levin, Howard Levin, all these biologists understood that, but physicists didn't want to accept that.
So let's get into psychology and neuroscience now. And I would like to ask you about the history of believing in a one-to-one identity between one brain and one mental event. So why is that important here?
I think it just follows the same trajectory. The idea that one pathogen will give you one disease. Well, we learned very early on that, and now we know there are neurons in the digestive system. Apparently there are more neurons in the I shouldn't say this because I'm not sure this is correct, but I read it someplace. No more neurons in the digestive system, or as many as in the brain. It's the same neuron. And there are certainly neurotransmitters in the stomach and in the digestive system, but what they do in the stomach is one thing, what they do in the brain is another. So we should have known that in biology there is no one-to-one, but we believed that if we studied hard enough, we will be able to identify with 15 billion neurons, we'll be able to identify this neuron is so-and-so's face, right? And this neuron does that other thing. And when the Human Genome Project got developed, and the assumption was one gene to one disease, one gene to one trait, kind of like hair color or that, but one gene per disease. Like, you know what? This isn't going to work because you're forgetting all the rest of the context. That same gene will express itself differently in one context, and in one context it'll be pathological, in another one it won't. Okay? So when you go then to the brain, I think we've assumed the same thing. And after behaviorism, and Skinner and so on in the 1950s and 60s had their heyday, and that didn't quite work. We weren't able to, didn't work very well. So then the next philosophy of mind theory was what was called the identity theory. The identity theory was that there will be that a thought, a feeling, an emotion, a sensation, all of these being considered mental events, would be able to be reduced to and identified with one brain event. Okay?
Right.
Right. Very quickly, I think that became disavowed because, for example, we know that there are cases where if the part of the brain that controls sight is damaged, very often the neurons will innervate the adjacent portion of the brain and will reproduce sight. So that one-to-one right there is shot, correct? And we understand how, and we don't understand how in a amputated limb, well, but if the limb isn't there, there is no signal going to that part of the brain, so how come I still feel pain?
Right.
So the one-to-one just didn't work. And then the identity theory tried to modify it by saying, well, it's not that that pattern in the brain identifies pain, but rather it's one particular instance, so your brain neuron here might cause your pain, but it might be my neurotransmitter there that causes my brain. But then the question is, well, but you're not going to ever get any science out of that, because you need to explain what the causal, what the commonality is with respect to pain. So then, and I saw that you interviewed Patricia Churchland.
Yes.
What became very popular at the time, Patricia and her husband Paul Churchland, was what was called eliminative materialism. And that was, well, you know what? There really is no mental state at all. It is just all is going to be explained in terms of neural patterns. And I've got to say, I think I've said it on another podcast, but I've got to repeat it because I get a kick out of this. Paul Churchland came to visit here in Washington, D.C. a long time ago. And I asked him, well, have you ever considered complex dynamical systems theory? No, not interested, not interested. And what I find fascinating is that his son, Mark Churchland, is the preeminent neuroscientist that is advocating dynamical systems patterns in the brain, which I think is it. Because what you have in dynamical patterns is that they can be multiply realizable. And I make a big deal about that word and concept in the book. Multiply instantiated. And again, I go back to my Bernard cell example. My Bernard cell example is convection cells can occur in water and in many other types of viscous fluids. So they're not one-to-one of the material cause with the higher level organization. No, it's a dynamic constraint regime that we call the Bernard cell, and probably it's a constraint regime that we call my thinking of my grandmother. And maybe 6 months from now, an awful lot of things have happened that the neural connectivity is different, the neural dynamics are different, but when I think of my grandmother, it's not the neural patterns that are identical. They're not identical in the same individual over time. They are certainly not identical between two individuals thinking of the same thing. So what is it? And it has to be some kind of constraint regime. And what I mean by constraint regime are all the interlocking constraint enabling and context-independent constraints that somehow at one point coalesced into my grandmother, just like they coalesce at one point into Bernard cell, or they coalesce at one point into tornado, or they coalesce at one point into this ecosystem. You know, and again, in an ecosystem, individual plants may come and go, individual fish may come and go, individual predators may come and go, but the ecosystem constraint regime holds within a certain level of viability. If it exceeds that level of viability, the whole thing will break down. So if I get, I don't know, meningitis or I have a bad concussion, that constraint regime may not hold. And it seems to me that, for example, these studies of either electroconvulsive therapy for depression or for post-traumatic stress disorder, or now there's a lot of talk about hallucinogens and so on. I think what those might be doing is to reorganize the constraint regime of the neurons, the complete interdependent dynamic that maybe got stuck at some point and is no longer accepting new input from the environment. And so I am fascinated by the idea of structure, function, and regulation. And I would call the constraint regime the regulatory level. And so a soldier who comes back from Iraq or wherever and jumps at the sound of a backfire in the car behind me, the brain is, the structure of the neuron is fine. It is responding to an alert signal fine. It's just that it's no longer regulating it given the context it's in right now. So it's as if the setting, the set point is off. And what needs to be regulated is the set point, not the function, the structure. Those are working fine. It's when it kicks in and when it stops. And that is the and there are regulatory genes, there are regulatory dynamics in the brain. And I think those are the ones we understand the least. And I suspect that mental properties, and especially things like, oh, you know, I can't stop in front of a chocolate brownie without stopping and eating it, whether the self-regulatory, the self-constraining regulation there is not as strong as it could be, and why do some people who are in Iraq not get PTSD and some do? And so it has to be something to do with the regulation. And so that is the kind of thing that I think the identity theory just was not able to handle, because they were assuming one neural pattern to one process. And it just doesn't work that way.
And so in cognitive science, there's this, what now people call 4E cognition approach: embodied, embedded, enacted, and extended cognition. In what ways would you say an approach based on constraints tie to that kind of approach in cognitive science?
I am very amenable to the 4E approach. I think it is very compatible with what I'm trying to say. I think it started out with authors like Merlin Donald, The Origins of the Modern Mind, which is fascinating. Of course, Andy Clark, who's a friend, was one of the early proponents of it. People like the author who wrote the book about, you know, what is it like to be a bat? Is the mind just in the brain
Thomas Nagel.
Exactly, Thomas Nagel.
Yeah.
We understand now that the mind is, it started out with the mind is embodied. It is not just in the brain, it is embodied in how we use a pencil and we write. It helps us understand. There's a wonderful new book now out that's called Thinking with Your Hands. And how, you know, we always, I can't talk without having tied my hand down, you can't talk. But people used to think it was just expression. But no, but there's been recent studies done. You should get that author on the podcast, Thinking with Your Hands. It's about gesture. And it is how the mind is embodied. Mental processes are embodied in gesture. It's not that the gesture is expressing what's in the brain. It's that it is part of the mental process. And that sometimes you can have children understand a concept better if you have them actually doing it with their hands and so on. So initially it was that the mind is embodied in the body. But then the notion of practices, and Mark Bergauer is always talking about practices. Practices are not just behavior. They are a contextually embedded pattern of behavior that therefore is influenced by tradition, temporal constraints, right? Yeah. The tradition of the watchmaker, the tradition of the leather tanner or the tailor, that sort of thing, correct? And these are constraints that are handed down in the community, and that the person becomes a practitioner and therefore becomes adept at doing this. And we now understand, for example, that a concert pianist encodes the movement in a different part of the brain than the person who's just learning how to play the piano, where it's, you've got to think each, but that's true for almost every skill, every practice. You know, you learn how to play tennis and you're going, oh, well, now I've got to move my leg here and I got to move, but after a while, what we think of as flow becomes what? A constraint regime that takes over. And then if the constraint regime is operating, then you just let the world be its own model. I think that's Andy Clark's phrase. You let it be its own model, because then, but think, if for everything you did, you have to encode one, I mean, you use up the 15 billion neurons pretty quickly. But if you only have to encode the brain as saying tennis, then you can just let the context-dependent constraints take care of themselves, because the constraint regime of that task is determining the possibilities. And so that was enacting. And then I think the enacting goes with the embedding, because I don't think just if you're a Martian and you just drop into that practice tradition, you don't automatically perform it. You have to be embedded in that tradition. So you have to be embedded in the temporal constraints as well as and so what I say in the book is that my only issue with the 4E approach is they never explain how that whole dynamic comes about, where the person is embedded in a practice and is enacted. And I think the idea of enabling constraints and constraint regimes can explain how all of these levels come about, how they emerge. And then, of course, they would explain how in each particular different dynamic it plays out. So I think I'm very amenable to that idea.
Yeah, as are many people that come from dynamical systems approach, right? I mean, for cognition, even at least to some extent, stems from that approach in cognitive science.
I don't know. Well, Merlin Dollar goes way back earlier than that. He was quarreling against behaviorism and the idea that you have a black box and this and that and the other. But he expanded it to the use of a pencil and how literally, I mean, I realize that when I write, the actual movement is part of my thinking process. Some people don't. Some people sit and stare at the wall for ages, and then when they start writing, it's first draft, it's last draft. But I think many of us, you cannot learn to ride a bike by reading a book. You actually have to do it. And what is that? It's what Kussling and Koenig in that book called multiple constraint satisfaction. You've got a whole bunch of constraints that all have to kind of go together, and you kind of learn how to adjust each of them. So finally, the emergent, coherent dynamic holds, and you're able, and the bike goes, and you don't fall off. So I think, of course, once the complex dynamical systems approach from people like Prigogine and people like Harold Morowitz and the Santa Fe Institute kicked in, then I think people saw the parallels. People like Brian Arthur's approach to economics as a complex dynamical systems is the same thing. An economy is not something other than the individuals participated in the trading, and now we understand, and they are embedded in a particular culture that constrains what they do and so on. But that is what an economy is. It is not something coming in from the outside. It is not, it is a coalescing, dynamical, coherent whole, which can, one of the chapters I never expected to write in this new book was the chapter where I talk about those constraints like entrenchment. You know, these constraint regimes can become very entrenched, especially in social systems. And sometimes I think social scientists understand how to entrench the constraints they want entrenched. And they may pass social regulations and social rules and so on that make it a lot more difficult for that constraint regime to adjust if the context changes. That may make that system very stable, but it will also make it very brittle, because once that outside system changes, and the system that coalesced under the earlier administration, right, won't be able to adjust to the new one. But while it holds, those folks who want entrenched social dynamics do a very good job of that. And I don't think we understand how that works as well as we should. I think that's the next area of research, is how do all these constraints play out? I want to start calling it the constraintome, just like there's the genome and there's a proteome. Well, there's a constraintome, right? That how they all play out, that we don't, especially in society, especially in development of children, we don't understand how maybe at one point the child becomes fixated by a certain, and maybe we call that a certain form of autism. How does that happen? That what was working fine as a constraint regime suddenly froze and became entrenched, and then it doesn't accept new inputs from the environment and adjusts and modifies to the whereas nature and evolution selects for resilience, not for stability. Stability can become rigid, can freeze, can become very rigid. Resilience is the ability to modify and continue. It's the multiple constraint satisfaction along with the context. And I make a distinction between context and environment, because I think Newtonian science talks about the environment. So efficient causes are coming in from the outside environment. But I want to use the word context and embeddedness. These are conditions that are part of what I am. But if they become rigid, then I can't continue. That interdependence that is me can't continue to grow, can't continue to adapt, can't continue to evolve, and people become fixated and very rigid. And you wonder, what are the constraints that cause that? Is it insecurity? Is it that if you're so insecure and you don't quite know how to handle the context in which that has changed around you, then, I mean, some animals, it's either they freeze in the, deer, there's a lot of deer near my house, and they will freeze in the headlights of a car. Some flee, right? Yep. Some learn how to adapt, and these mosquitoes that cause dengue and Zika, they do best around human beings. They've adapted to the saucers of the planters, and it's that standing water that they like. And so they've adapted, and mosquitoes and cockroaches and these animals, they are very resilient. They will modify themselves, and whereas some people just will freeze and that's it, then they will get killed because the environment then will act as an efficient cause and will roll over them. Exactly, they won't be able to adjust to the conditions. We don't know. How does that work?
Yeah, so let me ask you about one last topic then. Yeah. So since the very beginning, we've been talking a lot about causality, and at a certain point, you also mentioned that you were interested in understanding how intentions how intentions themselves can be causes. And so from a psychological / neuroscientific perspective, how can we understand top-down causation and understand how things like intentions, thoughts, beliefs can cause anything at all?
Again, in complex dynamical systems theory, these context-dependent constraints create attractors. Mm-hmm. Whether it be the Lorentz the butterfly, or they are attractors in dynamic state space.
Okay. With
emergent properties. We've established that is typical of all complex dynamical systems. When human beings, when I don't know if it's most mammals, but it's certainly human beings, we're born with a lot more neurons and experience by providing context-dependent constraints, begins to shape and sculpt, I think, dynamic attractors in the brain. I speculated about that in the first book, and the research by those neuroscientists like Churchland and Mante, that Chenoy, that whole school of folks have shown that, in fact, there are attractor dynamics in the brain. If that is true, and attractors have emergent properties, then I would want to say that semantics, content, the content of our thoughts are the emergent properties of these attractors in the brain. And I say in the brain because they are in the brain, but they have forged in construction with the whole 4E dynamic because of the practice, because of the context, because of all these multi-dimensional, multi-scalar, multi-temporal constraints as we grow up. And what finally convinced me that that was probably true was more than 20 years ago. And I'm very pleased that Geoffrey Hinton is now such a big deal with AI. It was papers by Gerald Hinton, what's his first name? David Plaut and Chalice. And I always call them Hinton, Plaut, and Chalice because Hinton and Chalice published, Plaut and Chalice published, Plaut and Hinton, Chalice. So they published a lot of papers. And this was have been 25 years ago, more than that. They published a paper, several papers on early neural networks that would be able to read words. And with feedback and, backprop algorithms and all that. And they looked, and then they started lesioning those networks below the feedback loops. They looked at those neural networks that had been trained without feedback loops and those with feedback loops. Ones with feedback loops ended up being the interesting ones. Feedback loops, yes, thank you. Circular causality, a la Kant, catalysts, all of these things that are constraint dynamics, correct? So that worked. And if they lesioned the system above the feedback loops, the neural network would make the errors that are characteristic of what is known as surface dyslexia. Before I read those papers, I'd never heard of the difference between surface and deep dyslexia. Surface dyslexia is what most people think of when they think of dyslexia. Instead of saying for like this, you write it like this backwards. Or instead of saying cat, you say cot. Or instead of saying tag, you say tog. It just transposes, but there's no semantics involved. There's no meaning involved. But what was fascinating to me was if Hinton, Plaut, and Chalice lesioned this early artificial neural network below the feedback loops, and they would show them the input to the system was, for example, BED, bed. Mm-hmm. The output of that system could be, and often was, COT, cot. I found that mind-boggling. Why? The squiggle of BED does not look like the swiggle of SCOT. It was not a physical signal transposition. But the meaning of bed and cot keeps the semantics. Cot is a simple bed like the ones you use in battle. It's a simple, but it's a form of a bed. Or if they would show the neural network ORCESTRA, orchestra, the output might be band, B-A-N-D. And so people asked, how do you explain this kind of error, And when I was looking at ChatGPT, I was going, this is so familiar. And the answer that Hinton, Plaut, and Chalice gave, the only possible explanation is that in the middle layers of the system, it self-organized a semantic attractor. So I went, if a silicone system, and it was very early on, can organize a semantic attractor, there's got to be some of that that's happening in the brain. And that's why I included in the almost the penultimate, the last chapter of this new book, the work by Churchland and Mante. Mante shows that in experiments with macaque monkeys, training them how to pick an answer on a screen, that what seemed to be happening was that a linear attractor in the brain was being organized that symbolized for the macaque monkey, that represented, symbolized for the macaque monkey, the task it was being asked to do on that particular run of the test. Okay, this works. At least I'm not finding any empirical experimental evidence that contradicts what I'm saying. And so then, can you say the monkey understood what it had to do? The answer was, insofar as you think of an attractor in the brain as embodying semantic distinctions, yes. Is it self-aware? That's a whole different animal. And I wouldn't even know where to start. But I would suspect that feelings and what philosophers call qualia, the feelings, the sensation of the heat of the searing heat of pain, or the bright redness of color. Chris Matz reminded me the other day of an experiment about if you are an animal out in the forest and all you see is black and white, you can't really distinguish between a poisonous mushroom and a non-poisonous mushroom as you could if all of a sudden that attractor in the brain had an emergent property of color, qualia. When that is an emergent property, then you can say, all right, I'm not going to touch the red mushrooms, these red plants. And so the animal can learn to distinguish. It has opened up an entirely new space of possible distinctions for the animal that it didn't have before. So I have no doubt that feelings, emotions, in fact, the limbic system in the brain, I think, is the very first stage in which a new code, a new interface based on valence. Is this good for me or bad for me? Is this positive or negative? See, and that's the advantage of categorizing in terms of types that way, is that then you don't have to remember each specific case. No, I remember red, bad. I'm not going to touch that plant. Red, bad. It's going to kill me. And so you have a whole new level of emergent properties that we call mental. But what I certainly don't want to do is say that the atom has psychic phenomena, the way David Chalmers and all these people who are now into psychomonism, excuse me, but what that means is that they don't want to give credence to true emergence. What I want to say is that at each level of organization, you get chemical properties arise, then biological properties that are unique arise. But that doesn't mean the chemical properties are gone, doesn't mean the physical properties are gone. It's just you get a new level of emergence from a new level of organization. And so then the next level would be what's psychological.
Right.
Now, I never know if sociological may go together, because perhaps the psychological doesn't kick in until you have social animals like the bees and all these very primitive early organisms, but that are very sophisticated. And so you wonder to what extent a cognitive framework goes along with that they both emerge together, the mental and the social, which would fit the 4E notion very nicely. So that's for experimental, for empirical studies to determine, it would seem to me. But it works very nicely, because I would say, and Damasio's latest book, Antonio Damasio, who of course talked about emotions and being part of the, it's not just in the cognitive part of the brain, it's in the emotive. And there you've got all the neurotransmitters and everything else kicking in at the same time. And he said valence, and what would be a precursor to valence? Proprioception. The ability to know where your body is in space is a feeling thing, but it's
Yeah.
not a feeling like in touch. And do you remember last summer, was it last summer, the summer before, in the Olympics, where that gymnast quit because the twisties.
Yes.
The twisties is the gymnast's notion of proprioception. If she doesn't know where she is at every point in that twist in space, she knows she's going to land in a way that's going to break her neck. And so she'd rather quit because I think it's the regulatory regime, the constraint regime that regulates that that is an attractor she forged through zillions of hours of practice and maybe some native ability and so on, that if that goes awry, then that's a serious problem. It's not just that this particular run was off. It's that the whole regulatory system went away. And obviously she's back, so she just won her recent competition. So the regulatory regime, her constraint regime, seems to have reintegrated or become more. So I think that works very nicely.
Yes. So, Alicia, I guess that this would be a good point to wrap up our interview today. The book is again Context Changes Everything: How Constraints Create Coherence, and I'm leaving a link to it in the description box of the interview. And just before we go, apart from the book, would you like to tell people where they can find your work on the internet?
Oh, it's an MIT Press book, so it is sold through the MIT bookstore. It's also on Amazon, and I'm very happy that MIT Press has made available e-access books for free. So I don't know exactly what the constraints are to access that book online. I think you probably have to go through some university or something to access, but it can be purchased for free. It is available for free through MIT. What's it called? E2 Direct or something like that. But on Amazon, it's available as Kindle and paperback, and then through this open access system. So thank you very much for the plug.
No, and thank you very much for taking the time to come on the show. It's been fascinating to talk.
Thank you. It's been a lot of fun. Thank you so much, Ricardo. You do a beautiful job. Thank you.
Hi guys, thank you for watching this interview until the end. If you like what I'm doing, please consider supporting the show on Patreon and PayPal. The links are in the description down below. And also please share, like, and hit the subscription button. The show is brought to you by Enlights Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters: Perga Larsen, Jerry Muller, Hans Frederick Sunde, Bernardo Seixas, Olaf Alex, Adam Kessel, Matthew Whittingbird, Arno Wolf, Tim Hollis, Eric Alenia, John Connors, Philip Force Connolly, Dan Demetri, Robert Windiger, Rui Inácio Zup, Marco Neves, Colin Holbrook, Simon Columbus, Phil Kavanagh, Michael Stormer, Samuel André, Francis Forte, Tiago Nunes, Fergal Cusson, Hal Herzog, Nuno Machado, Jonathan Librant, João Linhares, Stanton T, Samuel Correa, Eric Hines, Mark Smith, João Eira, Tom Hummel, Sadus France, David Sloan Wilson, Yacila Dez Araújo, Romano Roach, Diego Antônio Correia, Anik Punta, Radana Rosmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pablo Stazewski, Nelek Bach, Guy Madison, Gary G. Hellman, Simon Afzal, Adrian Yegi, Paul Tontino, João Barbosa, Julian Price, Edward Hall, Edin Bronner, Douglas Fry, Franca Bortolotti, Gabriel Pons Cortez, Ursula Litsky, Scott, Zachary Fish, Tim Duffy, Sunny Smith, John Wiseman, Daniel Friedman, William Buckner, Paul George Arnaud, Luke Loaki, Georgios Theophanos, Chris Williamson, Peter Wolozin, David Williams, Diogo Costa, Anton Erickson, Charles Morey, Alex Shaw, Amari Martinez, Coralie Chevalier, Bangalore Atheists, Larry Dealey Jr., Old Herringbone, Starry, Michael Bailey, Dan Sperber, Robert Grassi, Igor N., Jeff McMahon, Jake Zool, Barnabas Radix, Mark Campbell, Thomas Dobner, Luke Neeson, Chris Story, Kimberly Johnson, Benjamin Galbert, Jessica Nowicki, Linda Brandon, Nicholas Carlson, Ismael Benzliman, George Coriatis, Valentin Steinman, Paul Crowleys, Kate Von Goller, Alexander Hubbard, Liam Dunaway, BR, Masood Ali Mohammadi, Perpendicular, Jonas Hertner, Ursula Goodenough, Gregory Hastings, and David Pinsoff. A special thanks to my producers Isar Webb, Jim Frank, Lucas Stefaniak, Tom Vanagdam, Bernard Hugni, Curtis Dixon, Benedict Mueller, Thomas Trumbull, Catherine and Patrick Tobin, Giancarlo Montenegro, Alnick Ortiz, Nick Golden, and Rosie, and to my executive producers Matthew Lavender, Sergio Quadrian, and Bogdan Kanivat. Thank you for all.